Okay, so now we are in step 3 of the evidence-based practice model, and that is appraising and applying the evidence. And this is sometimes also called knowledge transfer, which is being able to take scientific information um, and making sure that it's clinically relevant to our patient. Okay, and so expertise comes and matters here. Experience with doing this matters. So you need to practice it and you need to make it part of your clinical approach. So, it should also happen both directions. I think that's really important, is that researchers should take what the clinician needs and wants to know and their experience and be able to produce evidence and research based on that. And so it's not just us as consumers of research. We might be promoters of research by saying, hey, this is a question I have and I need answers for it. And again, understanding what outcomes are important to you and your patient become important when we're appraising this evidence. So we're going to go specifically through a couple different types of articles or research, starting with systematic reviews, since there's such a great place to start. And all of you should definitely in your projects double check that there aren't any systematic reviews out there, or if there are, making sure that you read them and understand them and utilize them in your decision making. But some questions you want to kind of ask yourself when you're reading a systematic review. Is the systematic review valid? Okay, so is it of high quality studies that are relevant to your question? Systematic reviews of bad studies are just bad systematic reviews. So how do you know that? Well, the methods section should adequately describe what the comprehensive search was like, what terms they used, how they made their determination if this study was added or not added into the systematic review, and how the reviewers assessed the validity of each of those studies. So are the studies consistent that they looked at, both clinically and statistically? That helps minimize the chances of making an incorrect decision. Also thinking about, are there too few studies included, which could make understanding the concept as a whole potentially more confusing. Okay, so some key features, again, a strenuous effort to locate all the original reports on the topic of interest. So again, that really specific comprehensive search, a structured literature review that addresses the specific questions. Their conclusions are drawn on that preset criteria that they lay out. These are the studies and the type of studies that we're going to include before they even start delving into finding the studies. Is it a review of the right type of studies that are relevant to our question? So again, poor studies only begets poor studies. Does the method section describe how the trials were found and assessed? And are the studies, again, clinically and statistically significant? Or similar to each other, I should say. Meta-analyses, when you hear that term, that's a special type of systematic review where they actually run new stats. So because the studies are so similar, they're able to then pool the subjects into a larger population, or an N. And if we have more subjects, we can usually get a more accurate statistical analysis. And so, meta-analysis that integrates the studies might be something that you see or use as well. But again, you also need to think about, is it relevant to your question? Were the studies similar enough to run those statistics on it? Another thing to consider is publication bias. So usually publications really tend to want to publish things that have findings. And so we don't see as many inconclusives or negative results as much because people tend not to publish those. So that's something to keep in mind as well. Are the results important? Specifically, that means to you. Okay, so are they important to you and your patient? So considering, which patient group, intervention, outcome matters the most to you, can these results help you make those decisions? And ideally, we should also see confidence intervals reported for the results. If they're not, that's something that we can sometimes calculate. Most of the time that just means that's another little kind of red flag of, is this a quality systematic review? When we're looking at therapy articles, usually again are either cohort design or our randomized clinical trials. Again, is the study valid? So were there clearly defined research questions? Were the groups randomized? Were all the patients accounted for at its conclusion? So were there dropouts? And did the researchers try to explain why there's dropouts? So those are the dropout rates. A lot of that can depend on the length of the study too. We talked about those longitudinal studies. So do they just lose people because people move away, or they lose interest in the study so they don't participate anymore? Were the research participants blinded, and the researchers? Again, that takes into account the placebo effect. Were the study or the groups managed the same? Again, those strict protocols that we talked about. Are there equal groups? Did randomization produce comparable groups at the start of the trial? So randomization is great, but if even randomly we end up with all females in one group and mainly males in the other group, they're maybe not the same. And so then any comparison, how do we make comparisons? Was the length of time adequate? We talked about that. Like, was the follow-up okay? Was when we were studying points of interest that a real clinician would have in these cases? Again, are the results important? So the effect that we see could be because of 3 reasons. It could be bias, right? The researcher did something or was aware of something and changed results. The subject was aware and kind of changed their attitude and changed the results. It could happen because there's a chance variation between the groups. Like I said, even with randomization, are those groups actually looking similar enough? And there's just going to be some random chance. And then there's the actual p-value, which would be the actual effect that we see. So when you see a p-value of 0.01, means 1 in 100, a 1% probability that the results are coming strictly by chance. Okay? If the p-value is 0.05 or higher, usually we talk about that being significant difference between the groups, and then we can maybe potentially trust those results. Okay? So the bias we account for based on the methods and what we read and see how much bias might be implemented in. The chance is just going to be there. But what the p-value helps us determine is how small is that chance. And so if we see p-values greater than 0.05 or 0.01, our typical numbers, then we know that if there is a difference, it's probably due to an actual difference and not just chance. Another thing you can look for is confidence interval. That kind of helps us with the p-value as well. So confidence intervals, 95% is usually the go-to. So that means a 95% chance the population's true value lies between those 2 limits. So again, just another way to say statistically significant. The effect of the treatment, like I said, is playing into the, that's what we want to see. So we don't want to see that it's because of chance. And so p-value and confidence intervals tell us that. The effect is then that difference in what we call the event rates. And so if you need to review event rate stuff, there's a little bit of information here, but it's also in those additional videos. But basically, is there enough difference between a pre and a post? That would be 2 different events. Or between 2 different groups, that's 2 different events. Okay. You want to also look at the outcome measure that they used. So any feature that is recorded to determine the progression of the disease or the problem being studied. So it should be objectively defined. You should know if it's a valid and reliable tool. They should provide that information in the methods. They should also usually report the outcome in mean values for the whole group. So again, thinking about the therapy articles, did they frame a clinical question? Did they search for evidence? And again, this is kind of you doing this as well, framing your clinical questions, searching for evidence, assessing the methods used to carry out the trial. So that's what we've been talking about, reading those methods and understanding those methods. Determining a number needed to treat. So ideally this is hopefully in the article itself, or again, there's a couple videos up on Moodle that can help you determine your number needed to treat and decide whether that number needed to treat is something applicable to your patient, while all the time incorporating your patient's values and preference into this decision making. So if you find that injection is the best course for patellar tendonitis, but your patient doesn't believe in medications and doesn't want to use medications, then it doesn't really help you. That's not taking your patient's value into account. So like I said, we can measure or kind of rate the evidence. I already showed you the hierarchy of evidence. That's really just strictly based on the type of study it is, not necessarily how good the study is. These ones get a little bit more on how good the study is. So we have high, moderate, low, and very low. So this is just a fun kind of scale of further research is very unlikely to change our confidence in this study. So think about that. If new research came out, we feel so confident about this article that ideally new research would probably either match it or that we would really look closely at that other research to see if it compares. Moderate further research is likely to have an important impact on our study's confidence. Low is to have a very important impact and very likely, and then very low would be you can't really take anything this article is saying for any certainty. Another tool that is used is what's known as SORT. This is actually what the position statements from the NATA use. So A is a consistent, good quality, patient-oriented evidence. So patient-oriented, that means if they're using healthy subjects, it automatically can't be an A. If they're using animal subjects, can't be an A, right? It's not patient-oriented. B, inconsistent or limited quality of patient-oriented evidence. And then C, consensus disease-oriented evidence, usually practice, expert opinion, case series, all those would fall under C. So pay attention next time you read a position statement for a class, and you'll notice, especially in the more recent ones, they'll start rating the evidence A, B, or C.